Okay, so we are going to obviously keep on going with exponential equations. Now today, again, we're going to learn a lot of stuff. I'm going to show you 3 different ways to do each question. Well, maybe we won't do each question 3 different ways, but I'll say, okay, let's do these this way, and then we could do them another way, and then a third. Now, we're really going to deal with exponents today. Now, there are a couple exponent laws that we have to... I am taping. Yes, thanks. I could tell you had the "are you taping" face. The 2 big exponent laws, or actually 3, is if you have a m to the n. Okay, so you see how we have an exponent to an exponent. Okay. What do we do with these 2? We multiply it. This would be a to the mn. So an example would obviously be a3 to the 2 would equal a to the 6. Okay? Another law that we need to know very well today is if you had 1 over, say, 2 to the 8, this is the same thing as 2 to the Any guesses? What would that equal? 2 to the... Can we shut the door behind us, sir, please? Thanks. Yeah? It is. It would be 2 to the negative 8. Okay? When you take a power and you move it from downstairs to upstairs or upstairs to downstairs, you must change the positive to a negative or negative to a positive. Similar, if you had 2 to the 6, that would equal 1 over 2 to the negative 6. Right? Because I have moved the power from upstairs to downstairs, I must change the exponent from positive to negative. Okay, that's huge, right? And maybe those are the only... The other one that we're going to talk about is if it's this one here, and this is we're going to use a lot. If you have a to the m equals a to the n, so you have 1 power equaling 1 power, and the bases are the same. These are called the bases, right? I mean, we could even use B, because it would be a better letter, because we like to use A somewhere else, right? In front of the B. So if you have B to the M equals B to the N, you can actually, only when the bases are the same, you can actually cancel them like that, and M equals N. So what would be an example that I'm trying to say? Well, if you had 3 to the 4 equals 3 to the n, what must n equal? Okay, so we would drop them both. 4 would equal n. Like, does that make sense? That 3 to the 4 should equal 3 to the 4th? Right? But here's where it can get a little bit different. What if I had 3 to the 7 equals 3 to the n plus 2. Now, that means that I can just cancel the 3's and it would say 7 equals n plus 2. Now, how would you find n? Subtract 2, 5 equals n. So to test it, that's like saying, well, 3 to the 7 equals 3 to the 5 plus 2. Does that make sense? Okay, so we're going to need to know those 3 rules today. To be able to get through this lesson. Okay? And one more thing that we can always do too is graphing with y1, y2. Okay? So we'll talk to that. And then I'm going to show you another thing on your calculator to even help you get through these. Now, here's the kind of questions we need to do. Now, these numbers, I need you to write down 2, 3, 5, 7, 10, 11, and 13. Okay? 99.999% of numbers all can be divisible by those. Okay? I could get up to 17 and whatever, but for the ones we'll be doing in this course, all of them will be divisible by those. Now, the whole part of this is to find out what x is, right? Because x is our exponent now all the time. Hence being exponential equations, right? Now, by looking at a, what would you say x would be? Eight to what exponent equals 64? 8 squared equals 64, right? So x equals 2. Remember, don't put 8 there. Does this mean 8 times 8? That means 8 times 8 times 8 times 8 times 8 times 8, 8 times. Okay? That's way bigger than 64, right? So now, so that there's actually like 4 ways to do it, I guess, if you want. The trick is, though, if you can't see it right away, right? Now, you can also guess and test, right? You could put in 1, 2, 3, 8 squared, 8, 3, right? Till you get it. So that's even another way. Now, here's the way that we're going to, and we're going to need this more for the other ones, but 8 can be divisible, if it can be divisible by 2. If this number can be divisible by 2, I always want you to use this. I want you to convert 8 to 2 to the something. Okay? Now, 2 to the what equals 8? Cubed. 2 times 2 is 4, times 2 is 8. So, instead of 8, I want to write this again. 8x equals 64. I'm going to write this. 2 cubed to the x equals. Now, you see what I've done? 8 has been replaced with 2 cubed. Now, 64, since it's an even number, right, 2 will work. 2 to the what equals 64? Two to the 6. Now, do you see how we have our bases the same? Well, first of all, we want to get, what does that equal if I multiply those together? That's 2 to the 3x equals 6, or 2 to the 6. It's an x. Okay, now because the bases are both the same, what can I do? Cross them out. So therefore I have 3x equals 6. How do I find x? Divide by 3, divide by 3, x equals 2. So I got 2. We got 2 this way. Now what's another way we can do it? Okay, that's where we can get this out. Oops. Okay, and we're going to go to, I want you to turn your calculator on. This is where we're going to put the left side into our calculator. The left side is 8 exponent x, just like that. That's the left side of the question. In the right side of the question, I'm going to do 64. Where those two meet will be my x, will be my answer. So if you hit zoom, 6, standard, right? You do not even see where they meet. But here's something you have to, since we put y as 64, do you understand that my y max has to be at least 64 or I will not see it? Okay? So, you know, and don't put 64.3 as your y max. Put like 80 or something, right? So we'll go y max, and we're going to put 80. Why? Because it's bigger than 64. And I'll be able to see it nice. There's the first one. There's the second one. Here's our answer right there. So we're going to go second, trace, 5, enter, enter, enter. X equals 2. Okay? So let's write that. This is one way to do it. This is a second way to do it. A third way to do it is you go y1 equals 8x, 8 to the x, sorry, y2 equals 64, graph. Okay, and then we got a graph that looked like this. Okay, like that. And then we find intersect, and we got x equals 2. Now, what if you're just horrible at exponents? Like you're like 2 to the 6, would have never got it. Million years. Okay? Well, here's another thing you can do with your calculator. So let's clear both of these. Now, when I say 2 to the x, and I put it in like that, my x variable is the exponent. Okay? So when I put 1 in there, 2 to the 1 gives me 2, 2 to the 2 gives me 4, 2 to the 3 gives me 8. Okay? So instead of graph, hit second graph, and it will go to table. Now, what is x? No, what is x in my formula? What is x? What does it stand for? The exponent. So that 1 means 2 to the 1. 2 to the 1 equals, look at the answer. 2 to the 2 is 4. 2 to the 3 is 8. 2 to the 4 is 16. 2 to the 5 is 32. 2 to the 6 is 64. Okay? So I can have my entire, there's 2 to the 17. 2 to the 18. Okay? That's 2 to the 19. Now, because x is my exponent, that's the 2 to the 19 is this. Okay? So if you're even, you know, you're going to put it base 2, I converted 8. Okay, so 8 is 2 to the third. Do you see how I have 2 to the 3 equals 8? So instead of 8, I can put 2 to the 3. They mean the same thing, right? Is everyone kind of seeing this? Okay? And on the other side, see how I have 2 to the 6 down here? Look, 2 to the 6 is 64. So there's my 2 to the 3, replace the 8, and 2 to the 6, replace the 64. Okay? So there's the fourth way that you can use you can go about it is in y1, go 2 to the x. And then how did I find out, see all that stuff? What did I do? Second graph, which is table. Now, there's one other thing too. Again, I want you to be like maestros with this calculator when you walk into the diploma, right? So you got to know everything about it. Do you see this right here above window? What does it say? It says table set. Now the way you do table set, you go second window, and you can say where I want my table to start. I want to start at 2, and I want it to go up by 1 every time. But maybe I want to start at -2, right? And I want it to go up by 1s. Then I will hit second table, and now it starts at -2. So 2 to the -2 is 0.25, which is 1/4, right? 2 to the -1 is 0.5. 2 to the 0 is 1. Okay, and that's all done by second window or table set. What I want my table to start at and what I want to go by. Okay, So this may seem a little daunting, right, learning all this stuff at once, but you know, that's what the homework's for. If you're practicing this stuff, if you're learning it 10 minutes before the diploma, like, good luck, right? But if we're learning it now and we keep using it and using it and using it, your chances are better. Now, here, it's 2 to the whatever. It's already there. By looking in your calculator, 2 to the what equals 1. Okay? 2 to the 0 equals 1. You look right on your calculator, second table, there I am. 2 to the 0 equals 1. And how do I know my exponent is the x? Go to your y equals. Look, I made the exponent x. And what is y? The answer. Okay, so if I put a 5 in here, 2 to the 5 should give me 32. Well, let's see if that's right. 2 to the, gotta go down 1. 2 to the 5 is 32. Okay, so whenever you're at a loss for, you know, you don't have to memorize them. If you know how to use this, it is going to make your life easier. Now, anything to the 0 power equals 1. Well, anyway, t would equal 0. Okay, we do have to establish what t equals. Now, you're going to have to get also good at these by knowing, well, which one of these should I use? Now, like I said, all of these are going to get you through 99.999% of them. But some of them give you hints. See the 13 to the n? Okay. Now, what is 169? Well, you're like, no idea. Couldn't tell you. So how about you go here and go 13 to the exponent x? And then hit second. Okay. Now, remember what my base is. It's 13, right? 13 to the 0, 13 to the 1 is 13. 13 squared is 169. So, I am going to convert 169 to, this is 1 over 13 squared. Does everybody see what I did there? Is 169 the same thing as 13 squared? Yes, so I haven't changed the question. Now, the next step, I would like my 13s both on the same level. So this would be 13 to the n. This would be what on this side? No, never change the base, ever. 13 to the exponent negative 2. Okay, never ever. I don't know if you need to have like blinking lights on your study sheet or whatever. Do not ever, like this drives me nuts. I'll get like 1 over 4 squared and people go like this. Try it in your calculator. It will not work. You will not get the same answer. Okay, never change the base. Okay, one of the biggest mistakes that students make. Okay, now what is n? N equals negative 2. Is this the only way you could do it? Okay, what's another way? y1, y2, right? So y1, 13 exponent x. y2, 1 divided by 169. Okay, then I'm going to zoom 6 it, because that always brings me back to home. Okay, now, that's not looking good, is it? Like what? Where's the other one? Okay, is it my y max? What is 1 over 169? That's a pretty small number, right? So, see, this is why we don't want to be freaked. Like, this is where we run into this stuff, not on a test where you're going, whoa, I can't see anything, right? It is probably cruising along here somewhere. Okay? So you can change your window settings to be smaller now, because that's a small number. Do you see 169 is a big number? But 1 over 169, that's like if you had one pizza and you divided by 169 people. You're not eating a lot. Okay? It's true. That's what that means. So that gives you that. That's small. So you could hit zoom in. So that's number 2. But when you do that, nothing happens until you hit enter after. See, there's that one. Come on. Where are you? Okay, where is it? Still not even showing up. It's so close. Okay, yeah, you could do that. Go to your Y2 and maybe darken it. Hit enter with the dark. There it is. Okay, it almost looks like it's under the line, doesn't it? But go your second trace, 5, enter, enter, enter. -2. Okay, so y1, y2, right, dot, 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 we get x to equal -2 as well. How's this looking? Weird? Confusing? Okay, well, just in case you were getting it, I got D for you. Okay, now, if you can ever get rid of radical signs, do it. Does anybody know what square root is in exponential form? No. Square root x is the same thing as x to the 1/2. Okay? This brings you all the way back to math 10, right? Like if you had the 5th root of x to the 3, that equals x to the 3/5. Okay? And the way that I always get my students to remember it is Tybo. The top goes on the inside, the bottom goes on the outside. But you should always know, and this is good study sheet stuff, right? Square root x always means x to the 1/2, because there is an invisible 2 here. Do you see that? There is an invisible 2. Squared doesn't have a number there, because it's so famous. It's like, you can say Oprah, everyone knows who you're talking. Like, who? Who? Oprah Winfrey. Oh, Oprah, you know? They know, right? Cher doesn't even have a last name, she's so famous, right? Square root, they don't put the 2 there because it's so common. But there's a 2 there and actually a 1 there. Okay? So then I would first change this to 3 to the x equals 27 to the 1/2. Now what would you do? What's that? What do you see here? A 3. Can we do 27, 3 to the something? What is it? How can you find that out? If I was going to use my calculator, what would I put in to find out? 3 to the exponent x, hit second table, 3 cubed equals 27. Right? Is everyone with me there? So 3 to the x equals 3 cubed to the 1/2. Now I really haven't done any math yet, have I? Like all I'm doing is converting it so the bases are the same. Now what would you do next? Can't cancel out the bases yet till you get those exponents together. Now these are doing what to each other? Timesing. So put this over 1. 3 over 1. And when you multiply fractions, you multiply the numerators by the numerators and the denominators by the denominators. 3 times 1 is 3. 1 times 2 is 2. So now 3 to the x equals 3 to the 3 over 2. Therefore, what is x? X equals 3 over 2. Okay? Now, Some of you are probably going, I would have just graphed that one. But we got to be ready for both, because the diploma has a lot of what I call Jane or John questions, where John will do a question and they ask you, where did he make his mistakes? Now, this could be the question. So you're going to look and you're going to look at this step. Is anything wrong? No, that's right. Okay, and this is what it has. A, B, C, or D. Where is the mistake? Now, in this case, we didn't make a mistake. But if you don't know how to do it right, you don't know how to identify when they did it wrong. Okay? And maybe they'll add these or something, and they'll have the addition here. Right? They will make a mistake somewhere that you have to identify where it is. So y1, y2 isn't always going to help you, because you may get, oh, you found they got the wrong answer, but you don't know where they made the mistake. Okay? But anyway, just to quickly do this one in your calculator, 3 exponent x on this side, root 27 on the other side. We'll go zoom 6. Okay, you should get an exponential, hence the name of the game. There's the other one. Then we go second trace, 5, enter, enter, enter. You get 1.5. Now, here's another trick that your calculator does. Maybe you know it, maybe you don't. If you get out of here, go to the other screen, and now you hit X, your normal X button, and you press equals. It will bring back the X from that graph. Now, why is that helpful to me? If I want to change that to exponential notation. So then you can go math. Oops, I think I got to, let's see if I can do it from here. Math, enter, enter. Yeah. So it'll convert it to fraction for you. If it was like 0.218463, right? Get to the other side, quit, go x equals, it'll print it out for you, and then you can convert it to fraction. Okay? This thing can do a lot of good stuff, right? The more you learn it, and that's with the homework, right? Like if you're not practicing in the homework, you just did it with me, you probably won't be successful on the quiz or on the test. Okay? Now, let's do these algebraically. Now, do you see A? We have 10 to the x. Now, remember, is that one of my top numbers? Okay, so we want to make this 10 to the something, because if I do that, x equals to something, right? It's 10 to the, put it in your calculator, 10 to the x, find it out for me for sure. 10 exponent x, table, it's that quick. 3, right? Is that what you got? Okay. See how easy? If you know the trick. This is that table thing. That's mine. I can patent that baby. Okay? You won't learn that anywhere else, I promise you. Okay? So now x equals 3. We just did it algebraically. Okay? Okay, so on B, we have 3 to the 3x plus 1. Do we understand, to be able to do this question, I need to get this 3 to the something. 3 to the what equals 81. Come on, 3 exponent x, table. That's how quick you should be able to do it. No guessing and testing. Look at that table. You sure? Okay, just wanted to make you sweat a little bit. Yep. Okay, so everyone with me, how we got that? 3 to the x, table. Okay, you should be able to do it that quick. Yep. Okay, so I would always do this. You go second table. I would always start at, I don't care, you could even do like -5 or 0, right? Often 0 is going to get you, I don't know if -0 is going to work. And then I'd always go by ones. Okay? And I'm not set up here, obviously. I got to go 3 exponent x. Okay, then second table, 3 exponent 4. Now what do I do? I'm going to cross these out. Why? Because the bases are the same. I can do this. So 3x plus 1 equals 4. Then what do I do? Okay, -1 to both sides. 3x equals 3. Now they're almost insulting me with this. divide by 3, x equals 1. And you know what? And I'll tell you right now, like on the test, I have this underneath the question. I give you a question just like this on your written response, right? And then it says check underneath. I want you to do this. 3 to the 3 times 1 is 3 plus 1 equals 81. 3 to the 4 equals 81. You're going to put 3 to the 4 in your calculator. You're going to get 81 equals 81, right? I'm going to get you to check it, right? Remember, we are not going for 50 in this class, right? We don't even want 80. Right? We want a crappy day, everything went wrong, and I got a 90, right? So if you're checking that, you're going to find your mistake. Okay? What would you do in C? Yep. Okay, well what we should do this first. Change 16 into an exponent. Let's do that step first so I don't lose anybody. What is 16? Now do you see how 4 is the base here? Try that one first. So when you see that, now 2 would work too, but 4 does work because we know 4 goes into 16, but take the time, right? I even have 3 in there. You just hit 4 and then go second table. Oops, second table. Now I gotta wait for it to graph. Second table. I have 4 squared equals 16. So 4 to the 3 is 1 over 4 to the 2. Okay, don't skip this step. Some of you guys like to skip steps so you can get the wrong answer faster, okay, which is a huge waste of time. I'm assuming you're skipping steps to save time. But if you're skipping steps and getting it wrong, you've wasted more time than the guy that didn't do it at all, and you get the same mark as him. Okay? So take the time, do this step. Oops, why do I have a 3? That should be a 3x. Now what should I do? Okay, so if I flip this, this will be 4 to the negative 2. Now what can I do? Cancel these 4's, and I have 3x equals negative 2. Then what do? Divide by 3, x equals negative 2/3. Okay, I'm just going to get rid of this. Okay, now this one says solve by graphing calculator. Let's see if we could do A without a graphing calculator. Now, do you see how this is a 5 and this is a 5? Now that 5 has an exponent of 2x on it. What's the exponent on the 5? It's a 1. If there is no exponent, I guarantee you it's a 1. Now how could I write that so 5 would be on top? Okay, does everyone see what I just did there? It was 5 was on the bottom as a 1. I brought it up top as a negative 1. Now, what's this negative 1 doing to this exponent? What has it always been doing? It's power to a power. This is power to a power, right? There's an exponent to an exponent. Do you see? Exponent to an exponent. Those are both exponents. I did it the very first thing. What are those two doing? What operation? Multiplying. So you got to be careful here because this negative 1 is going to multiply to both of these. So this would be 5 to the 2x equals 5 to the negative 1x. What would be the other number? Negative 2. Now what can I do? Cancel that, so I have 2x equals negative 1x minus 2. Okay, how would I solve this one? No. I want to get all my variables on the one side. No, don't divide, because what is this number doing? It is adding and subtracting right now. It's not, okay? So we would add 1x here. If I added 1x, will it get rid of it? Yes, so I'm going to do that to this side too. So I will have 3x equals negative 2. Divide by 3, x equals negative 2/3. Now, I know that you guys would have no problem putting this into y1 or y2 and getting it, right? So let's just do it. In the first one, actually, this is important actually that we do this. We're going to put 5 to the exponent. Now, oops, when you have more than one thing, always put your exponent in brackets, or bad things will happen. 5 to the exponent bracket 2x. Okay? Why? Because there's just not an x there. Okay? So always, always, always put brackets. Now, number 2, or y2, always put your fraction in brackets, 1/5. To the exponent, because I have more than one thing, I am going to put brackets again, x plus 2. Okay, does that make sense? Okay, so now I'm going to hit zoom 6. So I always hit zoom 6 just by habit because I know it's going to get me close. Okay, so there is 2. See how they're both exponential? Right? They're both exponential. One was a, what's this one called? A decay. This was a growth. There's my growth, there's my decay. Okay, this is where they intersect. Second trace, 5, enter, enter, enter. Okay, so here's a good example. You're like looking at the multiple choice and there's no negative 0.666666 there, right? So you start freaking out. Pull, you know, your heart rate goes up a little bit. Just chill out. Get out of there. Quit. Second mode, which is quit. You can clear this. How can I change that to fraction? X, then press enter, then math, enter, enter. That's pretty conclusive that you got it right, okay? And again, this is for the students that are getting 100%. They need to be able to do it 2 ways, right? Did every one of you had a chance to go through your test more than once yesterday? No? A little bit? The more you know your stuff, the faster you can go through it. Okay, so you buy yourself more and more time. Some people were finished really quick, right? But they still had mistakes when they finished quick, right? So you got to go and find those. Okay, so B says use your calculator, but I don't want to use our calculator. I want to go totally old school on this one. 9 and 27. Okay, so when you see 9 and 27, you want to be thinking, which one of these? 3. Okay, I want you right now, while I get the door and I press pause, can you get both 9 and 27, put 3 to the something? Okay? Okay, so 9 would be what? 3 squared. 27 is 3 cubed. Now remember, the next step is not just drop the 3's. Remember, this is in brackets, right? And this is in brackets. So this 2 is going to have to hit both of those, right? Which would be 3 to the 2 minus 2x. Very good. This 3 is going to hit these two. Would be 3 to the 3x plus 6. Now what happens? Now you drop the 3's. Oops. So 2 minus 2x equals 3x plus 6. Now remember, the goal is always get all the x's on one side, get all the numbers on the other. Out of force of habit, I always put my x's on the left. Okay? And so I've been just doing it forever. I just do better that way. So I want to get all my x's on the left. I want to get this out of here, this 3x, right? I want to get it on the left. So what do I do? Minus 3x. And I will do the same here. So then I will get 2 minus 5x, because negative 2x minus 3x equals 6. Then what will I do? So I'm going to minus 2 now. I want to get this out of here. So I'll get negative 5x equals 4. Then what would you do? Divide by negative 5, right? So x equals, now you can put your negative wherever you want. I always put it up top. But just, you know, this equals negative 4/5. You can put it in the middle, or 4 over negative 5. This is usually, either one of these are fine. Just don't put two negatives. Some people will say, oh, that's like negative 4 over negative 5. No, because that's positive 5, right? Two negatives because of positive, so don't do that. You can put them wherever you want, top, middle, or bottom, but these are the most preferred. Okay, so we're going to do some y1, y2, because we got to know how to do them. Okay, now go to the original question when you do these, right? Don't put in your first step, because maybe you did your first step wrong. So what do I have to watch out for when I do these? Put brackets around what? The exponent. Okay, because if you do this, I'll just show you. 1 minus x, you know what this means? To your calculator, that's what this means. 9 to the 1 minus x. That's what it means to your calculator. It doesn't know, oh, you wanted all of that as an exponent? I didn't know that, right? So you have to tell your calculator exactly what you want it to know, because it's not a mind reader. And again, that's why we do it in class. So you know what your calculator does and doesn't do. Then on y2, we're going to go 27, and we're going to hit the exponent button, and we're going to make sure we put x plus 2 in brackets. Double check that they're correct. Hit zoom 6. Okay. Okay. Now something's weird, right? But it's actually happening way up here. Oops. Way up here in like outer space. But you don't have to see the y as long as you can see the x where it's going to happen. So if you go second trace 5, enter, 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 it made a liar out of me. Okay, so let me hit, did I put it in right? Yep. So I'm going to hit window, and maybe I need to get all the way up to like 100. Okay, so it's happening about here. I'm surprised it didn't work. Second before, but maybe that's good it didn't work. It's not even moving to the other one. Oh yeah, it did. Yep. Okay, so negative 0.8. You're looking at the multiple choice. There is no negative 0.8 there. Okay? So you just chill out. Quit. Hit x equals, and then math, enter, enter. Tell me that's not beautiful. Okay? So I do need you to know both ways for those Johnny, Jane questions, right? And it brings that more awareness as you're doing your questions. Okay, I want you to actually turn 2 pages to get, you'll see this, part 2 homework. Okay, what I want to start doing, we're just going to do a couple of these just so we can see how you're doing. Now what's a good base for A? No, never use 1. 3, right? Now, what's the exponent on this one here, like this? What's the exponent here? No, don't put a 0. It's a 1. Because 3 to the 0 equals 1. 3 to the 1 equals 3. Right? Put it in your calculator. So 3 to the 1 equals, now, what would 9 be? It's 3 squared to the 2x. Do you see how I always put that in brackets? So 3 to the 1 equals 3 to the 4x. Very good. So 1 equals 4x. Am I done? No. You always have to have x isolated. What is 4 doing to x? It's multiplying, right? So make sure you divide. 1/4 equals x. Now, here's what you should be always doing. Now, I get it. You're doing your homework. You got like 20 questions to do. I'm not going to check every one. But if it's a test, okay, we obviously know what 3 to the 1 is. Let's do the other side. So 3 to the exponent, use my bracket. And then in this one, because it's a fraction, I have to put another fraction. 1, or we can do it just like it is. How about we go 2 times, and I got to use my 1/4. Do you see how I had to put 1/4 in brackets itself? Because it's a fraction. Oh no, why did I pick 9? I shouldn't have. That would be confusing. I should pick 9, right? Because I want to put in this. I want to see, is 1/4 going to give me the answer what? 3. Okay? So that's how you check it. That's how you know you got it right. Some of you guys came to me yesterday and you were choked because you didn't get 100%. I'm glad you were choked, right? But you need more strategies to make sure that you can get 100, right? Find those little mistakes. Okay? C. What would be a good base for C? 3, right? So we got to get 81. So it's 3 to the something. So we got 3 to the 5x minus 1 equals, I need this, 3 to the something. 3 to the 4? How'd you know that so fast? You did it on the thing? Good. Okay? You guys have no excuses now for not knowing all of these because you don't have to know them. Right? You can find them fast. So now I have 3 to the 5x minus 1 equals 3 to the 12x. Do not say 7x, please. Okay, then what do? Cancel the 3's. I have 5x minus 1 equals 12x. Okay, what should we do? Now, because I have an x on the right, x on the left, it might be more efficient to just get rid of this, right? Then I'll get them all on the right. So what would I do? Minus 5x, right? So negative 1 equals 12x minus 5x is 7x. Then I will divide by 7. Right? You always want to make sure you have 1x. So I ran out of room, but that would be negative 1/7 equals x. Now, could you y1, y2 that one and verify it? Absolutely. Can you put negative 1/7 into both of those x's? Did you y1, y2 it? Okay. Now, this is, I'm not saying this is hard, but this is the most difficult part of the whole unit, right? So, like I said, will there be lots of people in this province that go to the test without knowing it? Absolutely, right? You cannot be that person, right? You need to practice these. You need to go through them. You need to make sure you can get every one of them. Okay, we're just going to do one more. I think we did like something like how would you do G? What do you notice about G? is not even an exponential question, is it? Why? Why is this not an exponential question? Yeah? Yeah, exponent is an x, but doesn't mean I can't solve it. At this point, I'd go to y1, y2. So 3x to the exponent. Remember, that is a fraction. I need to put it in brackets. If you don't put it in brackets, just write a little note on your test. Mr. Trimble, I did not put this in brackets, so it is wrong. You don't even have to mark it. Thanks. And you can sign it. Okay? That'd be helpful. And then I don't have to waste time trying to mark it. -2 is my y2. Hit zoom 6 because I have no idea where my last graph was. Oops. Zoom 6. That is a very good sign that wasn't exponential. There's the other one. Okay, and there would be my answer right there. Second trace, 5, enter, enter, enter. Okay, now you're like, okay, you look at multiple choice, there is none, so I'm going to get out of here. I'm going to press X, enter, and then I'm going to go math, enter, enter. I know there's a little part of you thinking this is fun. You can admit it. It's okay. You don't have to be all cool. I can see you smiling out there. Okay? So, yeah, and I will. Okay, so have I done enough of these that you're kind of getting it? Now, honestly, you need to do a bunch of them because watching me do it, it'd be like watching somebody play basketball for 20 years and like, oh, I rock at basketball now, right? You might want to get out there with the ball, see how it goes before you start bragging, right? Where's my calculator? Here we are. No, seriously, students are like, I get it, man. I don't have to do anything. I heard everything he was doing. Okay, we good? Okay, so I want you to just, if you go back to here, very bottom, I did not give you the homework. Your page 150 to 151, 1 to 5. And then the homework we were just doing. Okay, I want you to do the 6.3 homework. Just, yeah, it's part 2. So I want you to do 1 and 2. Like I've done a bunch with you. Again, use your phone for good. Have it out looking at the solutions, right? And try all the different ways. Make sure you're using your table function to find out all the exponents, right? The less we have to memorize, the better. The more that we can do with this calculator. Like if you really, really, really know how to use this calculator well, everything that we've been doing, if you have a really, really crappy day on that diploma, you'll get a 90. Okay? I know, you're like, yeah, whatever, but you just wait. Okay, wait till you walk out of that diploma. It'll be just like you walked out of that last test. Right? Some of you were mad that you didn't get 100. You thought you were the one that got 100. Probably it was your small mistakes that killed you. Okay, remember, nice and quiet for those people that cannot handle the noise.